everyone, how are you doing? As you can see, I am doing a face check, which means once in a while I just cut my beard to check that the face is still underneath. Seems to be still there, so that's a good one. And in this video, we are going to work with the physics library of Jitter, so the jit.phys objects library, which is something that I never really did in depth. So we're going to make a whole series of tutorials about this stuff. And in this first video, we're going to start taking a look at jit.phys.multiple and the collision reporting in the phys world. So as you can see, we got these visuals. There is a circle of cubes and a bunch of spheres inside. When the spheres hit those cubes, they light up, and there will be a little rubbery sound when the sphere collide with the circle of cubes. So this could be pretty interesting. It's not super simple. It involves involves a bit of patching, but will be fun. So without any further ado, let's dive into it. So let's start from the very scratch and let's create our jit world. Our jit world contains already a physics world. So give me one sec. Enable it, floating it, sizing it. What else do we want? Erase the color to black. It's always cool. Guess that's it. It's enable, it's floating, it's there, and it contains already inside jit world, there's already a phys world object. Because there is also an object called phys world, and we could create it externally from the jit world, but it's actually already inside it. So we can send to this object inside the jit world messages with the message prepended by send phys. So actually we could make like a prepend send phys, and then we could send messages to the phys world inside the jit world. Cool. Good. Now, we are going to create our objects using jit.multiple and jit.phys.multiple. So jit.phys.multiple, it's an object that we connect to jit.multiple, and it will control it. Applying to the objects that we draw the physics rules. So let me show you how this works. We got a jit.phys.multiple. We need to give it a number of inlet, like for jit.multiple. Now we have to say which parameters we want to control, and these are called phys params. Now the phys params are the position is a physics param, the scale, and then we could apply some forces to these objects. Now in this video I think we are not going to apply forces to the object through the jit.phys.multiple, and especially now we are going to create the circle of cubes. So these They don't do anything, they're just there as physics bodies, they're just there to be collided against. They will not have any forces applied on them. Good, I think so. This is it for the moment. Let's just give it a name and call it like a circle of cubes. This is the name of this jit.phys.multiple object. We will see later why this is important. And for the moment, that's it. Now we want to create a jit.gl.multiple, which is going to be controlled by these phys.multiple. So we just need a couple of inlets. These are going to be our GL params position and scale. Actually, we need also the color. Let's add the color as well. So we need 3 inputs. So now the phys.multiple has 2 outputs. The position, so the position matrix that we connect into the jit.gl.multiple, and in this case it has also the rotate matrix, which we don't need. Because we are not rotating our cubes for the moment. Maybe we will do it later, maybe not, doesn't really matter. So with the phys.multiple, we're just going to control the position of the objects rendered by the jit.gl.multiple. Okay, so let's create our target object to render, which is going to be simply a jit.gl grid shape with a shape cube and automatic 0 because we don't want it to render. Let's color it white. There it is. Let's color it white. Yeah, let's color it actually blackish, like gray, 0.2, 0.21. Good. Now we need some matrices to fill these phys.multiple. So we're going to, of course, to use jit.gen for that. This is going to fill the position, scale, and that's it for the moment. So we're going to connect this here. This is our jit.gen. We're going to need another output, because one will be the position, other one will be the scale. So for the position, we say we want to make a circle. So first, let's say that we have an input matrix, which is going to be 3 planes, float 32, 40 in 40 cells, which means we will have 40 objects. So we connect this here, and let's say that we connect it directly to the output of the jit.world. So this is going to bang it every frame. And cool. So if we want to make a circle of cubes, we need to create a circle by using, for example, the cosine of the normalized coordinates for the x and the sine for the epsilon. We multiply this first by 2 pi. So we have a complete circle. There it goes here, there it goes here. And we use this as the x and epsilon. Right. And let's see. Okay, we need also to fill the scale. Let's fill it like with a fixed number, like, for example, 0.15 for all the axes. And we need to send these also to the GGL multiple, because otherwise it will not have a scale. So we need to send the scale actually both to the phys multiple and to the GGL multiple. Cool. And actually we don't need to have 3 inlets here. Sorry, I don't know why I wrote 3. I thought I was thinking something else. Let's write actually 2, because we only have 2 phys parameters, position and scale. Now, as you can see, this is not working. Well, it is actually working. It's just that it's rendering the cubes in black, because I didn't give it any colors. So we want to give it a color. Let's create another output here. Let's say that we want a color of... no, let's actually not do it here. Let's not do it inside this jit.gen. Let's create a matrix, jit matrix for planes, because it's colors 42. We got 40 cells. And let's just set all those cells with 0.2, 0.21. Exactly, that's the color we wanted to give to the object. Actually, we don't need to give the color here. Let's actually set it to white for the grid shape itself, because we're just going to give it a color through the GGL multiple. So bang it actually, and there we go. There are our cubes. Cool. Actually, there is a cool object when working with physics, which is called jit.gl. It's actually a GL object, which is called phys.draw. And this will draw, let's get this enable attribute. This will draw all the physics bodies that are in our world. So in this case, every cube has attached the physics bodies, because we got a phys multiple. So let's actually get a camera to move around in this world. So I'm going to create a jit anim drive UI listen 1 speed, I don't know, 10. And then we need the actual camera. So GGL camera. Look at 0, 0, 0. We will just look at 0, 0, 0. Lock look also 1, and I don't know, tripod 1. This will be it. Let's create a message to reset this position. Good. And now we can move in our patch using the WASD keys. Oh, okay, that looks cool. But what is happening here is that the shape of the GGL multiple phys body by default is actually a sphere. So we should go in the phys multiple and say that we want to use as a shape for the physics bodies a cube. So now we can see that every one of these cubes has its own phys body cube attached. Now let's see what happens if we just don't send this matrix anymore. Poof, they just fall to the floor. And we could even pick them up with the mouse if we use an object called jit.phys.picker. It's a cool object which lets us pick physical objects in a phys world, objects that have a phys body attached. And yeah, that's cool, but that's not what we want. So at the moment, there is gravity in our physical world. So this phys body, every phys body reacts to gravity by default, unless we set it with the kinematic set to 1. If we set kinematic to 1, these phys bodies are not going to interact with the forces of the world. Exactly. So as you can see, if I set kinematic 1 and then bang again the position, the bodies are just going back where they should be. And if I say kinematic 0, they will just fall down, right? So kinematic 1. We don't want these bodies to have any forces applied, right? We don't want them to fall down with gravity. So what we want to do is to give kinematic1 to this phys world. So kinematic1, let's hard code this attribute. Very well, let's bang again this matrix, cool. Let's make this circle a bit bigger. So let's create a parameter here, let's call it like circle. This is going to be our circle radius, I guess. So let's set it to like 3.5 or something. And let's multiply both the cosine and sine by this. So multiply by circle radius. Both the sine and cosine. You could do this all in code box, but it's actually not much code we are going to write here, so there is not really any need. All right, there we go. There are our cubes, and as you can see, actually you cannot see it, but this cube here is overlapping with the cube behind it. So they are always colliding, and this is actually no good for us. We don't want these cubes in the circle to collide just like that. So what we want to do is to get a slightly less smaller circle than 2 pi. So we're going to do like this, multiply this by 2 pi minus, I don't know, 0.1. See how this looks like. Okay, now they're not colliding anymore. I would like them to have a bit more distance though, so I'm just going to try again until I get a good result. So 1.2, 1.3, 1.4, 1.5 maybe. This looks pretty okay, 1.6 maybe. Oh, 1.5. Okay, 2 pi minus 0.15, it's good. So now they are not overlapping. We have a full circle of stuff, of cubes, which is great. Let's check our frame rate, jit FPS GUI. Looks okay, it's steadily at 60 frames per second. Now, let's create our spheres that will bounce on these cubes. So what we're going to do is something very similar. In fact, we could just copy this whole thing. Let's maybe encapsulate inside a subpatcher. So these are, we call it circle, no, cubes, circle, right? For some reason they're gone because the color here. Okay, we're going to set this color then later in some way. We're going to bang it. But for a moment, we just need to bang it again manually. Let's duplicate that and say P, this is going to be spheres. Good. And we don't need to bang these at every frame. Actually, we don't need to bang even the cubes at every frame for the moment, because we are not moving them. So, but later we will need to bang them at every frame. So we leave this cable there. Now, the spheres, how many we want of them? We want 6 of them, I guess. Sounds like a good number. We want them not of a fixed color, we want them like of random colors. So we create a noise matrix for the colors. We got 6 of them, as we said, so, right. We have already an object called the circle of cubes, jit.phys.multiple, so we have to change the name for that. I think I'm going to call these spheres. That's good. And now they will just appear as cubes. If I click here, they will just appear as cubes on this circle of cubes. That's not what we want. First, they are not cubes, they are spheres. So, shape sphere. Secondly, the physical bodies must also be a sphere. And third, we don't want them to appear in a circle. We actually want them to appear in a straight line, let's say. So you can use S norm for that, and we're just going to use this as the X position. So boom, there they are. There they are, our cute spheres. And now we want them to fall onto these cubes. So if you remember, if we disable the kinematic, they are just going to interact then with gravity. And there they are, they just fell into the cube. Now if you notice, these spheres can also fall on the sides of this circle of cubes. And that's not what we want. We want actually them to live in this virtual 2D world inside this circle. So what we can do, is inside is to send a message to the phys world inside the jit world to remove actually one axis of movement. For example, the z axis. And we can do that like that. we can send to the physical object, to the phys world, the message remove plane 3, because the zeta plane is the third plane. So if we remove the plane 3, now you can see that when I move them with when I pick them with the mouse, they will always stay into this 2D space. Okay, sometimes they will just jump out of it. This happens because they go through the cubes. Actually, they're a bit too small, in fact. Let's make them a bit bigger, so the scale a bit bigger. Let's say, I don't know, 25. Let's see how big they get. Oh yeah, they're big spheres, big bodies. It's okay. It's okay to have them so big. Cool. We removed the third plane, so the zeta axis. Let's actually load bank that. Good. Now let's animate our circle of cubes. Let's make these rotate. So how do we do that? Let's actually delete that. We don't need that. We don't need to bang this at every frame through the method from the jit.world. Let's do like this. Let's get a jit time object. This will give us the time only when the jit.world is on, though. And we're going to, inside jitgen, we don't need the input true. We're going here to create another parameter and call it time, and starts with 0. And this is simply an offset that we're going to sum to our angle before it goes into the sine and cosine in order to animate the circle of cubes. Right? And let's connect this here. So let's go like this, prepend time. And we pass this first as a list to the jitgen, and then we bang the matrix. So we can do like this. First we pass the parameter to jitgen, then we bang this matrix, and well, there we go. They're starting to move. So they're actually moving. Let's change a bit the speed of these, like we can set it to 0.2, so they move a bit slower. And we can see the spheres rolling onto this circle of cubes. It's amazing. Every time I work with the jit.phys library, it's sort of amazing, I have to say, how this all works so smoothly and so nicely. You can have some very nice effects. I'm actually very impressed by all these. So, I guess we should actually have an inlet here to bang again these spheres in case they fall out of the circle of cubes. We want to get them back in. Good. This kind of a reset thing. Reset spheres. Cool. Good. We can also disable the phys draw just to get the actual objects without all the stuff around. So we got our setup. Is good, is great. What we need now is to check when stuff collides. Okay, so now it gets interesting. First, we will get the collision out of the third outlet of the jit.world. But in order to have that, we have to send to the phys object, to the phys world, the message collisions set to 1. So this will activate the collision reporting of the phys world inside the jit.world. Now, as you can see, we are getting a dictionary here. It's a dictionary full of collisions. So if I root collisions first, so we don't get any garbage out of that, we get this dictionary. Let's take a look at it. We send it inside a dict object. I think there is also just a dict showy thing, but okay. So here we have got a little dictionary that tells us which object is colliding with which other object. In this case, sphere 5 is colliding with the 33rd cell of the circle of cubes. Amazing. So we get the body 1 in the collision was sphere 5, body 2 in the collision was the 33 cell of circle of cubes, and then it gives us the position, the normal, the contacts, the duration of this thing, the impulse. It's amazing, the stuff that we get out of it. We can do so much stuff with that. But for the moment, we're just interested in it's collided or not. So what we're going to do is to iter. We're going to get all these dictionaries basically one after the other. So dit iter. If we print what's coming out of that, let's see what we get. There we go. We get all the dictionaries. Cool. One by one. So you can see that we get actually a message. We've written the name of the dictionary and then the dictionary itself. So the name of the dictionary is sphere, 3 spheres for, and then dictionary sphere, 3 spheres for. Cool. So we actually just wanted the info about the dictionary. So we're going to get away the first element of this list, which is the name of the dictionary itself, I guess. So I guess this is the name of the dictionary. So we slice that, and let's see what we get if we print that instead. Okay, so we actually get the actual content of the dictionary. Amazing. So let's check. We need to check now. We want to know when a sphere is colliding with a circle of cubes. So what we want to do is to actually iter this dictionary again. And what do we get if we do that? We get the actual elements inside these dictionaries one by one. We get them one by one. That's great. Because now we can root for body 1 and body 2. Because we always have two bodies in a contact, in a collision. The body 1 will collide with body 2. So if we check what's going on in body 1, it tells that this was the sphere X colliding with some other body, circle of cubes, for example. Amazing. Now we don't care when the spheres collide with each other, we only care when they collide with a wall, with a cube in the circle of cubes. So we need actually just to filter for circle of cubes. And we can do that using a regular expression with the regexp object. I'm by no means an expert in all of this regex stuff, so I just googled for a way to get the message only when it contains the word circle of cubes, and we can do it this way. Thanks to the power of the internet, I've discovered that we can do it this way. A question mark, less or equal than what we want to filter for. So circle of cubes. And this will also give us the number of the index in the matrix of the cube colliding with the sphere. So that's amazing. So sometimes it appears on the left, sometimes it appears on the right. So we just check for both these bodies. And what we get here is the index, should be the index of our cube. And it's not, because I forgot something. I also have to write dot plus. Don't ask me why, that's just how it is for regular expression. I don't know anything about this stuff. So we get the index now of the cube with which the spheres are colliding, which is amazing. It's great. Trust me, it's great. Because now we can use this information to, for example, lighten up the cubes. For example, let's do something like that. We can pack set cell 1D, and we can say, let's actually send these around in the patch. So send index cube, index collision cube, something like that. Let's send it inside our subpatch cube circle. Let's pass it here. There it is. So we receive it. And we say pack set cell 1D, this index, and then another color. I don't know, let's say, for example, let's say that we want to have a color of 0.5 for the red, 0.5 for the green, 1 for the blue, 1 for the alpha. And this is going to be our index, and we send this to this matrix. And once we finished to set this matrix, we actually want to bang it. Now, it's a bit inefficient to bang it every time we fill it. We actually just want to bang it once per frame, otherwise we will bang it every time we fill it with some color, which is not the best. It's not best in terms of efficiency. So what we can do is that at the end, after we got all the collisions, we can send this bang. Yep, so this will happen at the end when everything is already being set in that matrix. Let's call it collision bang. So what we need now is copy that. We go into cube circle, copy it here. Oh, it didn't copy it. Okay, collision bang. I think we called it. Yes. So we connect this and we bang this matrix. Once we finished banging all the setting all the collisions. Okay, cool. So as you can see, once a sphere collides with the cubes, they're going to be colored in this nice little color. Cool. Let's have a way to reset them once in a while. Oh, do you exit my circle of wall? of cubes. Okay. Let's reset these once in a while so that our cubes don't stay colored. So we can do it, for example, with a Q metro, 2000 milliseconds, active 1. So once every 2 seconds we are going to reset the colors. There we go. And cool. Now this looks good. We still don't have the sound. Maybe I think we're going to add it in the next video, maybe, with some other little things. But for the moment, I just want to end this video by making them a bit more bouncing. So we can set the restitution attribute of the jit.phys.multiple to something like 1.1 in this way. These spheres should actually bounce. They don't do. So let's go inside the phys.multiple of the spheres and set also its restitution attribute to something like 1.1. And now we should start to see some bounces. Yeah, there they go. There they go. If we change again the restitution here, let's see what happens. Yeah, this matters as well. So let's just hard code it here. Restitution 1.1 for the worlds, for the circle of cubes, and then in the spheres, restitution as well, the same line, restitution 1.1 for here. Cool, let's bang that. What did we do? Oh, kinematic is still set to 1 here, should actually be set to 0, so by default it's set to 0. Let's just leave it like that. Good, and we got our bouncing gummy bolts. And they color the cube with which they get in contact. So we found a way to basically filter the collisions from our cube. Funnily enough, after a certain point, they will just start to go crazy. So maybe 1.1 is a bit too much. Let's say, I don't know, 1.01. I guess it must be a bit more than 1 in order to not lose energy. Let's try something like that. Looks good. Looks good. Feels good to watch. And I think we're going to stop here with this video. It's an amazing world. We can go very far from here. This is just the beginning of our exploration in the Phys world. In the next video, we're going to see how to add some audio with MC stuff, so we get polyphonic sounds for the bouncing, and this is going to be fun. And thank you very much for watching. I hope you liked it, and if you liked it, actually, you can like the video, subscribe to the channel, check my Patreon page, which is full of this kind of stuff. You can get in contact with me, join my Discord community, and yeah, thank you very much again, and I will see you in the next video. Ciao.